All right, ladies and gentlemen, let's see what we got here. Today we're going to begin looking at some of the laws in algebra when it comes to exponents. So here, well, let me make that a little bit smaller. Here are the laws. This is actually on your algebra EOC math chart. Eventually we are going to look at all of these different rules, but today our focus is going to be this one and a zero. Zero is actually pretty simple. If we have a to the 0 power, and a can be any value, just so you know, this is 1. And we'll talk about that a little bit more in detail. This rule here, this one right here, if we have a negative exponent, we're going to be using. So for example, any number to the 0 power is 1. So let's look at what we have here. We have n to the 0 power. N, it doesn't matter what it is, so guess what? It's a 1. We have 4 to the 0 power. That has a value of, wait for it, 1. X, Y, Z, X times Y times Z, all of that to the 0 power has a value of 1. Now this one's a little different. This is like saying -1 times 2 to the 0 power. So 2 to the 0 power is 1, but we still have to multiply times a -1. So this one would actually be a -1 because that negative is hanging out front. A little bit of a special situation there. Go back to the reciprocal. All right, now, when we talk about that rule, reciprocal like we've done before, so we're going to take the reciprocal of the original number and make the exponent positive. So whether it's moving from a numerator to a denominator, we're changing it from a negative to a positive. So for example, this is n to the -3. I'm going to put it over 1 to make it look like a fraction. I'm going to take the reciprocal, so it's going to become 1 over n, and I'm going to make that exponent positive, so n to the 3rd. That's it. Same thing with the next one. I'm going to put it over 1. So this will become 1 over 4 to the 6th power. We can actually multiply that out as well. Let's see here. We got 4 times 4. Give me a second. I'm doing this the very long way. So there's 6 4s. So it looks like it would be 1 over 4,096. Not realistic, but yet that would be the value. All right, let's look at some more. Here I already have it written as a fraction. So now this x to the n is going to move up to the numerator. So it's going to be x to the n, positive n, over 1, or just x to the n. The next one, I'm going to make it into a fraction. I'm still going to move that 1 to the numerator. That -3 is going to stay in the parentheses, but the exponent on the outside will become positive. This one's a little bit trickier because of that negative. When there's parentheses around value, it stays that way. Now I can actually multiply this out. -3 times -3 times -3 becomes -27. So this would actually have a value of -1 over 27. Both of these are correct. It just depends on your directions. All right, here's another one. I want to write this one with negative exponents. So I want to write it without it being a fraction, essentially. So now it's already a fraction, so I'm going to write that x to the -2 in the numerator, and I'm going to put it over 1. So this really would be x to the -2. These two are interchangeable. One has positive exponents, one has negative or no fraction. So I could do the same thing here. This would become 10 to the -1. Technically over 1, but we can eliminate that step. Okay, more. Now this one is super tricky. I have the fraction. I'm going to rewrite it so it looks a little bit better. I have b over 5h, and that's all to the -2. So because there's parentheses and a fraction, we're going to take that fraction and we're going to flip the whole thing over. So it's going to become 5h over b. And now that 2 is no longer negative, it's just a positive squared, or positive 2. Okay? I don't know why those parentheses are all wongo. We're going to do the same thing here. So I have 8 over AB, and that is all to the negative 4. So I'm going to flip the whole thing. So this becomes AB over 8, all to the 4th power.